Okay, so welcome to this tutorial. We are going to be looking at a question that has to do with chapter 12, where we're comparing group means, and the presentation probably is going to be a little longer than usual because I do feel the need to generalize a little bit more than just answering this question specifically. So I hope you will be willing to invest the time. Now, the question reads, researchers collect samples of water from streams in a mountain range to investigate the effects of acid rain. They measure the pH, which is the acidity of the water, and classify the stream with respect to the kind of substrate, so the type of rock that the water is flowing over. A lower pH means the water is more acidic, and the plots are shown here, and we have three different types of substrate. There is limestone, and there's one with shale or shale, forgive me if I mispronounce it, and then there's one with a mix. Now we're asked to select the selected parts of a software analysis comparing pH of streams with limestone and shale substrates are shown below. Now, for the two sample t-test, mu1 minus mu2 is assumed to be 0. The difference between the mean that was found was 0.735. The t statistic was 16.30, and the experiment was done with 150 degrees of freedom, producing a p-value that was less than 0.0001. So that's sort of the background behind the information that we have. Now, comparing two means, we are always going to be looking at one mean minus another in two different instances. The two things we're trying to compare. In this case, the author is looking at one case where there was an offer and calculating the average, and another case where there was no offer. So it's always two contrasting things that you want to see if the difference is significant. So that's what it is. And in order to tell if the difference we observe in a sample mean indicates a real difference, because what we're saying is there was a difference in the mean of 0.735, but is that significant? Is that enough for us to say that the two substrates have significant effect on the pH of the water, or whatever it is that you are assessing? You might get a difference when you calculate the difference in the mean, but it may not be significant enough scientifically for you to jump to conclusions. So the first part of the question wants to look at the null and alternative hypothesis for this test. Now, just to sort of generalize, the null hypothesis is pretty much always supporting the status quo, that there is no difference, nothing unusual. So in that case, it would be that the values of mu1, and it's stated right here, the mean of one group minus the mean of another group is going to be equal to 0. So effectively we're saying that the limestone mean minus the shale mean is going to be equal to 0. And the alternative hypothesis, we are interested only in if they are different. We're not necessarily looking at one being greater than the other or vice versa. We're just wanting to say that they're either the same or they're different. So the null hypothesis is H0 is such that mu L minus mu S is equal to 0, and the alternative hypothesis is a two-sided. HA is such that mu L minus mu S is equal to 0. Continuing with part B, we want to look at the information to see if the assumptions are met. There are some assumptions that are intrinsic to this type of analysis, because there is some science that goes beyond what we are concluding, and it speaks about randomization and a 10% condition. It also speaks about normal, that the distributions are normal, and it also speaks about independence between the groups. So let's take a look at the response. Before performing a two-sample t-test, 3 conditions must be checked. The data in each group must be drawn independently and at random from its own homogeneous population or generated by a randomized comparative experiment. The next thing is that the data in both groups must be approximately normal. And finally, the 2 groups must be independent of each other. So let's check to see if those conditions are met. Independence and random, approximately normal, and the 2 groups are independent. There are 2 of these that speaks about independence. One is independence between the several data points within a group, and the other one is independence between one group versus the other group that we are comparing. It is unknown whether the streams were chosen randomly, so we assume that the pH of one stream does not affect the pH of another stream. The box plots that were given, there is some skewness to the box plot. You can see that the lower half is, or the lower portion from the mean is longer than the upper portion, so that suggests that there is skewness. Now, that the bigger concern is the outliers that are here and here, but generally speaking, with 150 degrees of freedom, which is what this problem had in terms of the data, the sample sizes are large enough for us to assume that the normal condition is met. The next one we want to look at is to describe the independent group assumption for this. The pH level from the 2 types of streams should be independent. There is no reason to believe that the pH of one group or one stream is affecting the pH of another. Therefore, we're saying that all the conditions and assumptions are satisfied. Now, what conclusions can we draw from this data here? Now, let's look at what this really means. And the p-value is a probability, and let's talk about what that probability represents. Now, this probability that's given gives you the probability of this being true and the result you get being consistent with this being true. So putting that in more practical terms to this problem, what they're saying, this probability is a 1 in 10,000 chance. So what we are saying is, if the difference between these two was 0, there's a 1 in 10,000 chance of you getting a difference this size. Now 1 in 10,000 is fairly unlikely. So if this is true and this is true, it only happens 1 in 10,000 times. I'm not going to bet my money on that. So what it means, this super small p suggests that the null hypothesis, which is here, which was given to us here, is very unlikely to be true. In other words, if this whole scenario, if this were accurate, it would happen 1 in 10,000 times. So the conclusion to draw from this, as stated by the authors, is that the p-value is the probability on which to base your decision. A low enough p-value says that the observed data would be very unlikely if the null hypothesis were true. So this super small p-value suggests to me that I should reject the null hypothesis, which is that the difference is 0, and accept the alternative hypothesis that the difference is not 0. Now that's what it is. Now, just to emphasize this point, I want to show you something that isn't related to the problem, but will absolutely help. In this situation, there was some calculation done with website and looking at the difference between two to see if something that was changed caused an increase in visits, and the results are a little different than we got in the problem. So let's look at it real quick. In this case, the t value was 0.588 and the p value was 0.5557. Now, what this is saying is that if the null hypothesis is true in that the difference is 0, then the difference that we observe would happen 0.5% of the times. Now, that is pretty high a probability. So therefore, with this size p-value, we would fail to reject the null hypothesis in that there is insufficient evidence to conclude that the mean number of pages per visit is different. Now, I just wanted to show you a situation where the p is higher, even though the problem that we handled had a super low p, which led to a different conclusion. So the essence of how you would make a conclusion is in the fact that if p is high or just not low enough, the data are consistent with the model from the null hypothesis, and therefore there is no reason to reject the null hypothesis. So if p is low, the null hypothesis is rejected, and if p is high or just not low enough, then the null hypothesis, there is not enough reason to reject the null hypothesis. Alright, it takes a little bit for you to bite into this, but I felt it was important to sort of digress a little bit from the problem. I'm hoping that this helps. If it brought about any questions, feel free to reach out so that we can assist with those, and I'm hoping that this helped with the problem. Alright, thanks.